I was actually thinking about language learning the other day.
Oh, yeah.
Yeah, because there's this really distinct phase you hit. You've memorized the vocabulary, you know the grammar rules.
Right. You can officially order a coffee without embarrassing yourself.
Exactly. You can order a coffee, you can ask for directions, but then you hear two locals actually talking to each other, and you realize you are completely missing the rhythm.
You're missing the idioms.
Yeah, the actual dialect.
I completely agree. That is the exact difference between just being functional and being truly fluent. It is a massive leap.
It really is. And, in software development, specifically within the Salesforce ecosystem, that gap is just huge.
Oh, absolutely.
It can literally be the difference between a junior developer who writes code that technically works and an architect who builds systems that actually last.
Yeah, because it is one thing to get a Lightning Web Component in LWC to just render on a page.
Right.
It is an entirely different ballgame to write code that is scalable, secure, and, doesn't just explode the second you hit a governor limit.
Or when you hand it off to the next developer 6 months down the line who has to sit there and figure out what on earth you were thinking.
Technical debt nightmare.
Exactly.
Yeah.
So today, we are bridging that exact gap. We are doing a deep dive into that transition from LWC novice to expert. And we are basing this on a really fantastic, comprehensive set of resources today.
We're looking at part 4 and part 5 of a 5-part blog series.
We are published over in the UK Salesforce Consultants and Contractors community on LinkedIn.
Which is such a great group.
It really is. And the author is Raksha Sanganee, who actually co-leads that community. So part 4 focuses on the definitive do's and don'ts, the actual technical habits you need. And then part 5 looks at the career trajectory for people who actually master this stuff.
And before we dive into the syntax in the code, we really should establish why we are listening to Raksha here. Because in the Salesforce world, credentials matter.
They really do.
And hers are honestly staggering.
Staggering is definitely the right word. She is a solution consultant and architect with over 5 years deep in the ecosystem. But what jumped out at me wasn't just the time in the seat, it is the breadth of knowledge.
Right.
She currently holds 14 Salesforce certifications.
14.
Including application architect and CPQ specialist.
Yeah, and CPQ configure price, quote, is just a beast in itself. That requires a very specific, highly logical mindset.
It does. But here is the real kicker. She also has 37 DevOps certifications.
Wow. See, that is the key differentiator for me. A lot of people can write JavaScript.
Sure.
But Raksha clearly understands the operational side. Deployment, CI/CD, how code actually lives and breathes in a real production environment. She is also a Capado Global Award winner and a Woman in IT nominee.
So this is not just theoretical textbook stuff.
Not at all. This is, I have seen production break and this is how you fix it. Advice.
Exactly the kind of guide we want for this. So let's jump right into part 4 of her series. She frames this as a to-do list.
Right.
But reading through it, it feels much more like a manifesto for habits you need to build from day one.
Definitely.
And the very first one hits on something that confuses almost everyone when they start with LWC decorators. Specifically the track and AMPI decorators.
Oh, this is the classic trap. You come from other frameworks, or maybe even the older Salesforce Aura framework, and you just want the screen to update when your data changes.
Right.
So the novice temptation is to just splash that track decorator on every single variable in sight.
It is the make it work button. You just want the UI to react to what you're typing.
It is. But Raksha's insight here is all about being deliberate with your resources. In modern LWC, basic fields are actually reactive by default now. You don't actually need track for a simple string or an integer. If you change a title property, the component already knows to re-render.
So when is track actually necessary then? Why does it even still exist?
It is for deep reactivity. If you have an array or a really complex object and you change a property deep inside that object, the framework won't naturally notice that specific nested change unless you use track.
Ah.
But Raksha's main point is don't use it if you don't absolutely need it. Every tracked property adds overhead to the browser's change detection cycle.
Because it's constantly watching it.
Exactly. If you overuse it, you are making the browser work so much harder than it needs to, which just leads to a sluggish UI for the user.
That makes total sense. It's really just about performance hygiene. And then we have the AP decorator. I always think of this one as hanging a public sign on a door.
That is a perfect way to put it. The API decorator exposes a property to the parent component. It allows data to flow down into your component.
Right.
The architectural lesson she is pushing here is encapsulation. You should only expose what is absolutely necessary for the parent to actually control. If the parent doesn't need to touch it, keep it private. It drastically reduces your surface area for bugs.
Speaking of surface area and keeping things clean, let's talk about something that feels administrative, but is actually highly architectural. Naming conventions.
Yes.
Raksha is pretty strict here.
And for very good reason. In LWC, naming is not just a style choice like it might be in Python or, general JavaScript. It is literally how the bridge between your HTML and your JavaScript functions.
Because HTML is case insensitive, right?
Correct. HTML doesn't care about uppercase or lowercase, but JavaScript is strictly case sensitive. That mismatch creates a very specific set of rules. Raksha breaks it down really clearly. Your files and folders need to be kabod case.
Meaning lowercase with hyphens.
Yes.
Ugh.
So my contact widget. But inside your JavaScript file, your class name must be Pascal case. So capital M, capital C, capital W, my contact widget.
And what happens if you just mess that up?
The system simply will not find the component. It just breaks. And going even deeper than that, your public property names usually need to be camel case. So if you have an AMPI property called recorded with a capital I, but you try to set it in your HTML as recorded with a hyphen, the framework actually maps that behind the scenes for you. If you break the convention, that mapping fails entirely.
So it's not just about being tidy for the next developer.
Not at all. It is about making sure the engine can actually compile and run your code.
It is so interesting how being tidy often translates directly to being functional in this environment, which leads perfectly into our next point, modularity. She uses the Lego analogy.
Everyone loves the Lego analogy, but I think Raksha applies it in a very specific, practical way here regarding debugging.
Right.
Because the novice tendency is to build what we call the God component. One massive file that fetches the data, processes the complex business logic, handles the error messages, and renders the list on the screen.
I have definitely been guilty of that in the past. It just feels easier to have it all right there in one place until it breaks.
Precisely. Raksha advises breaking it down relentlessly. Don't build a massive contact manager component. Build a contact list. And inside that list, don't write out the HTML for each individual contact. Build a separate contact item component.
So the list component just iterates through the data and drops in instances of that item component.
Exactly. And here is the real takeaway from her post. This isn't just for aesthetics, it is for isolation. If a specific button on a single contact card isn't working, you know exactly which file to open. You open the contact item file. You aren't scrolling through 500 lines of spaghetti code in a parent component trying to find one button.
Plus, now you can actually reuse that contact item on a completely different page if you need to.
Yes. You are building assets, you aren't just building pages.
That reusability is just key. Now, let's move down to the data layer. In the old days, and by old days I mean maybe a few years ago, if we wanted data, we wrote an Apex class. We queried the database directly on the server. Raksha seems to strongly suggest we should stop doing that so much.
She advocates very strongly for Lightning Data Service, or LDS. You can think of LDS as the standard library for Salesforce data.
But why is it better than just writing my own custom Apex controller? I always thought custom meant more powerful.
It can be, but custom comes with a serious cost. The big insight Raksha brings up here is caching and consistency. When you write an Apex call, you are making a dedicated, fresh trip to the server every single time.
Right.
But when you use LDS, like the Lightning Record Edit Form or the standard wire adapters, Salesforce manages a client-side cache for you automatically. If two different components on the same page need the exact same record, LDS fetches it once and shares between them.
So it is significantly faster.
Much faster. And it respects security rules automatically, which is huge. If a user does not have permission to see a specific field, LDS just won't return it. You don't have to write a bunch of custom if-is-accessible text in your code. It handles field-level security out of the box.
That is a massive time saver. Less code to write, less security compliance to stress about before deployment.
And it creates a beautifully consistent UI. If you use the standard LDS forms, your error messages look exactly like native Salesforce error messages. Your loading spinners look like native Salesforce spinners. The whole thing just feels native to the user.
Speaking of feeling native, the last item on her to-do list is about UI and accessibility.
Which is absolutely non-negotiable in modern web development. Raksha points straight to the Salesforce Lightning Design System, or SLDS. It is basically their built-in CSS framework. And her advice is incredibly simple. Don't write custom CSS if you don't absolutely have to. Use the SLDS utility classes.
So instead of writing a custom CSS class just to add some padding and margins, you just use the standard SLDSP around medium class.
Exactly. It ensures your app looks good on mobile, tablet, and desktop right away because those classes are already built to be responsive. And she pairs this directly with accessibility.
Right, for screen readers.
Yes. Using standard base components means you get all the required ARIA labels and keyboard navigation basically for free. If you try to build a custom button out of a simple div tag, it is completely invisible to a screen reader. But if you just use Lightning button, it is accessible by default.
Okay, so that covers the do list. Be deliberate with your decorators, strict with your naming, modular with your architecture, and lean heavily on the standard libraries. Now let's flip the coin and look at the don't do list. These sound a little bit more dangerous.
They are. These are the exact things that create massive technical debt or open up security holes. And the biggest one for developers who are coming from a general web development background is direct DOM manipulation.
Ah, the old document.query selector trick.
Right. In standard web dev, if you want to change a button's color, you grab it by its ID and you change the style directly. In LWC, Raksha warns us, point blank, do not touch the DOM.
Why is Salesforce so incredibly protective here?
It is all about the shadow DOM. This is a standard web technology that LWC uses to perfectly encapsulate components. Think of it like a sandbox or a force field around your code. It ensures that the CSS from my component doesn't bleed out and completely ruin the layout of your component and vice versa.
Makes sense.
If you try to reach in and grab elements manually using Query Selector, you are fighting against the browser's own security encapsulation.
So how do we actually change things on the screen if we aren't allowed to grab them?
Through data binding. You change the variable in your JavaScript file, and the HTML automatically updates itself to reflect that change. You have to let the framework manage the DOM. If you bypass that, you risk your entire code base breaking whenever Salesforce updates the internal structure of their base components.
Got it. Okay, next pitfall. Hard coding. This feels like Developer 101, but it clearly still happens all the time.
It happens constantly, even with experienced devs. Someone needs to filter a list by a specific record type, so they just paste the 18-character ID directly into their JavaScript if statement.
And I assume it works totally fine in the developer sandbox.
It works perfectly in the sandbox, until you deploy to production where that exact same record type has a completely different ID. Now your code is broken and users are submitting tickets. Raksha calls this making your code brittle.
So what is the proper fix? Just using custom labels?
Custom labels for static text, custom metadata for configuration logic, and APIs properties for passing IDs dynamically. Just never assume an ID is constant across environments. If you use custom metadata, a Salesforce admin can go in and update the ID right in the UI without you ever needing to redeploy a single line of code. That separates the configuration from the implementation.
I really want to zoom in on the most Salesforce-specific don't, she mentions, governor limits. This is the concept that I think really trips up people coming from backgrounds like Java or C#.
Oh, absolutely. The multi-tenant rulebook. Because we are all sharing the exact same server resources in the cloud, Salesforce is absolutely ruthless about resource consumption. Raksha's golden rule here involves loops.
Never put a SQL query inside a loop.
It is the cardinal sin of Salesforce development. Imagine you have a list of 100 account IDs. If you loop through them and run a separate database query for each individual one, that is 100 queries. Salesforce has a strict governor limit of 100 queries total per transaction. You will hit the wall immediately and the code crashes.
So the bulk safe approach she mentions means gathering all those IDs into a list first, right?
Exactly. You gather all the IDs into a set or a list, you run one single query to fetch the data for all of them at once, and then you map the results back together in memory. It is the difference between driving to the grocery store 100 separate times to buy 100 apples versus driving there once and buying the whole crate.
That is a really vivid way to picture it. Driving 100 times would be exhausting.
Yeah.
Now, what about mixing frameworks? There is still a ton of old Aura code out there in orgs. Can't we just mix and match Aura and LWC components?
You technically can, but Raksha strongly advises against it whenever possible. Aura is the legacy framework now. LWC is the modern standard based on actual web components. When you mix them on the same page, you force the user's browser to load both heavy libraries simultaneously.
Which slows everything down.
It is heavier, it is slower, and the communication events between Aura and LWC are just notoriously clunky.
So if you are building a brand new feature, keep it pure LWC.
Exclusively LWC.
Okay, the final don't is one that always gets a collective groan from developers. Don't skip testing.
It is the vegetables of software development. Everyone knows they should eat them, but nobody wants to. But Raksha is adamant here. Salesforce provides Jest for JavaScript testing, and her insight isn't just about catching simple bugs, it is about preventing regressions.
Meaning, making sure my brand new feature didn't accidentally break the old feature.
Exactly. If you have a robust test suite, you can refactor your code with total confidence. You can take that messy God component we talked about earlier, break it down into modular pieces, run your automated tests, and know for a fact that the business logic still works perfectly. Without tests, you are literally coding in the dark.
So that thoroughly covers the technical roadmap. But part 5 of Raksha's series pivots. It zooms out and asks, why does any of this matter for my actual career? She maps out some specific roles where this exact LWC expertise becomes the ultimate differentiator.
And this is fascinating to me because it shows how much the ecosystem is maturing and specializing. A few years ago, you were just a general Salesforce developer. Now, Raksha identifies the LWC specialist.
Is that actually a distinct role in the job market now?
In large enterprise companies, absolutely. These are the people focused entirely on the front-end user experience. They aren't just writing back-end trigger logic. They are obsessed with pixel-perfect design, strict accessibility standards, and millisecond load times. They bridge the gap between a UI designer Sigma mockup and the actual Salesforce platform.
Then you have the technical architect role.
Which is the massive level up. The architect might not be writing every single line of code every day, but they absolutely need to understand the deep capabilities of LWC. They need to know exactly when to solve a business problem with a simple no-code flow, and when the requirements are complex enough to actually demand a custom LWC.
Right, they design the overarching architecture.
Exactly. They design the data strategy to completely avoid those governor limits we just discussed.
She also mentions the consultant role. This one is really interesting to me because consultants often focus heavily on out-of-the-box configuration.
True, but a consultant who genuinely understands LWC has a superpower. They can look at a client's chaotic 20-tab spreadsheet process and say, I can build you a custom streamlined interface that turns this into 3 clicks. They don't just implement standard Salesforce, they tailor it entirely to the business. That adds massive, undeniable business value.
Raksha gives some fantastic real-world use cases where this kind of tailoring actually happens. One that really stood out to me was AI-powered service consoles. This feels incredibly current.
Oh, it is the absolute cutting edge right now. Imagine a customer support agent actively working a case. With LWC, you can build a custom sidebar component that actually listens to the live chat in real time, sends that text to Einstein Salesforce's AI, and then displays recommended knowledge articles or next best actions instantly on the screen.
So the LWC is basically the delivery mechanism for the AI.
Exactly. The AI does all the heavy analytical thinking in the background, but the LWC provides the slick, fast interface for the human agent to actually interact with it. Without LWC, that brilliant AI insight is just stuck in the back end.
Another huge use case she brings up is partner portals.
This one is crucial for brand identity. If you have external partners logging in to register deals or update leads, you do not want them seeing a clunky, generic internal database view. You want a branded, modern, consumer-grade web experience. LWC allows you to override the standard look and feel entirely. You can actually make Salesforce look exactly like your company's public-facing website.
And finally, she highlights mobile-first sales apps.
Because LWC is based on standard, lightweight web standards, it runs beautifully on mobile devices. You can build highly custom apps for field sales reps that feel exactly like native iOS or Android applications, allowing them to literally update their sales pipeline with a quick thumb swipe while walking between meetings.
It really reinforces that moving from just learning the language to truly mastering the dialect opens up these incredibly high-value visible projects. You aren't just in the back room fixing bugs anymore. You're building the primary interface of the business.
That is the ultimate career unlock. You transition from being viewed as a cost center, just someone who fixes IT tickets, to a massive value creator for the company.
Raksha wraps up the series with some really solid advice on where to go next. She mentions the usual paths: freelancing, moving up in enterprise roles, but she also touches on the app exchange.
Yes, the entrepreneurial route. Because LWC is inherently modular, remember those Lego bricks we talked about? You can literally package those bricks up.
No.
If you build an incredibly useful, highly functional project management timeline component, you can package that specific component and sell it on the App Exchange. You can actually turn your code into an independent product.
That really brings us right back to that fundamental shift in perspective.
Yeah.
When you adopt these strict naming conventions, when you decouple your logic perfectly, when you test rigorously with jest, you aren't just writing a quick script for today. You're building a tangible asset.
That is exactly the thought I want to leave the listener with today. Raksha's advice on modularity isn't just about code organization, it is an entire development philosophy. Stop building pages. Start building tools.
I love that.
When you build a robust, totally reusable LWC, you are creating a tool that other developers on your team or even your future self can use to solve problems significantly faster down the line.
You're moving from a simple page builder to a genuine tool builder.
Exactly. And as Raksha says right in her conclusion, trust the process. It absolutely feels slow to set up the jest tests initially. It feels tedious to make sure you are naming files perfectly with kebab case.
It really pays off.
It does. That daily discipline is exactly what separates the absolute masters from the amateurs.
A truly powerful roadmap for anyone looking to seriously level up their Salesforce game.
Indeed. Go out there and build some solid bricks.
That is it for this deep dive into Raksha Sanganee's LWC insights. We will see you on the next one.